Good evening everyone. Today we'll solve some problems on inverse border plot. So what do you mean by inverse border plot means? They'll give you the border graph and we need to find out the transfer function from the border plot. So the main use of inverse border plot is to find out the open loop transfer function from the border graph. So we'll see what are the steps involved in finding out the transfer function from the border plot. So the steps are, first of all we have to observe the initial slope which will gives you the poles and zeros at the origin. In the graph, if you observe the initial slope, that initial slope will give you what are the number of poles and zeros which are located at the origin. For example, if the initial slope is minus 20 dB for decade, this indicates there is one pole at origin which is nothing but 1 by s. If there is minus 40 dB for decade as an initial slope, which indicates there are two poles at origin and it will contribute to 1 by s square. Similarly, if you have 80 dB for decade, which means 80 is nothing but we can write it as 2 into you can write as 20 into 4, which means it is positive. So which means there are zeros. Each zero at origin will contribute 20 slope, and there are 4 such zeros at origin which are contributing 80 dB for decade. So which means there are 4 zeros at the origin and the transfer function is s power of 4. So while by observing the initial slope, we have to find out poles and zeros at the origin. And the second step is we have to identify the corner frequencies, so at which there is a change in the slope. These corner frequencies where there is a change in the slope will give you finite number of poles or zeros, simple zeros at that frequency. So to find out the change in slope, the formula is the change in slope is given by new slope minus old slope, new slope minus old slope. So after finding that, you have to write in the form of plus or minus 20 n into the power of dB by decade. Then you can say 1 plus s to the power of omega c plus or minus n is the transfer function. So at that corner frequency, we have to find the change in slope. Change in slope is found out by new slope minus old slope, and at that how much slope you get, you have to write in the terms of 20 into n, and that will give the number of either poles or zeros at a finite frequency. Next, at the last, we need to find out the value of k from the known omega c and known magnitude. So these three are the basic steps which were involved in finding out the inverse border plot and finding out the transfer function. So we'll see sometimes to find out the k value, if the magnitude at omega equals to 1 is given, then simply you can find out the log k value from 20 log k. So like this, and some other steps are there to find out the k value. We'll see those steps in following problems. So we'll see one problem. This is 8C problem from the question paper 6. Find out the open loop transfer function of a system whose approximate plot is shown in the figure. So if you see this figure, in this figure there is a border plot which is having different slopes. One is minus 20, next minus 40, and next minus 60 at different corner frequencies. You can observe the initial slope is minus 20 dB up to the frequency 2.5. The initial is given started at 1. So 1 to 2.5 the slope is minus 20 dB. From 2.5 to 60 it is minus 40 dB. Up to 40 it is minus 40 dB. From 40 it is minus 60 dB. So for this we'll find out the transfer function from this border plot. So when you observe this, you can find out simply the initial slope. First step is you have to find out initial slope. The initial slope is minus 20 dB. As you know, the initial slope will give the number of poles and poles at the origin. So the initial slope is minus 20 dB for decade, which means there is one pole at origin whose transfer function is 1 by s. Since by observing the initial slope we can say there is a one pole at origin. Next, at omega equals to 2.5, this log omega axis, at 2.5 there is a change in slope. So at omega equal to 2.5, the change in slope, the change in slope from, what is the change in slope? You have to find out. New slope is minus 40 dB. This is minus 40 dB. Old slope is minus 20 dB. So new slope minus of old slope. Old slope is minus 20. So the total slope is minus 40 plus 20, which is nothing but minus 20 dB for decade. Since which indicates minus 20 means there is one more pole, finite pole or simple pole at omega equals to 2.5, then the transfer function is 1 by 1 plus s by 2.5. Right? So next you can observe up to 40 there is no change. At 40 the slope is changed from 40 to 60. So at omega equals to 40, the change in slope is minus 60, that is new slope minus old slope is minus 40. Now this is minus 20 dB for decade, which means again minus 20, which is nothing but pole. So this is again 1 by 1 plus s by 40 is the transfer function. Now up to 60 you have three parameters, that is 1 by s, one more factor 1 by 1 plus s by 2.5, next 1 by 1 plus s by 40. So these three factors you got, and finally you have to find out the k value. To find k value you will follow the rule y is equal to mx plus c, slope formula. So y is equal to, the initial slope is m and log omega plus c. So y is at any particular one of the slope they given you the magnitude. At 2.5 they given you the 40 magnitude. So your y component is 40 and the slope is minus 20, this initial slope, and log omega value you have to take as 2.5 plus c. So from this you have to find out c. The c is given as 40 plus 20 log 2.5, where c will be 48 dB. From this your 20 log k should be equated to this 48. From this log k is equal to 48 by 20, which is 2.4, and the k value is 10 to the power of 2.4, which is 251. Right? So now the total transfer function is 251 k value. Later on you have one pole at origin. Later on you have one pole at 2.5 and one more pole at 40. So this is the overall transfer function of the bode plot. You can simplify further if you require.